Given that log base 3 of 3b plus 1 minus log base 3 of a minus 2 is equal to minus 1, where a is greater than 2, I need to express b in terms of a. So let me use the laws of logarithms on the left-hand side here. I'm subtracting, so I'm going to use the division law. Like that. Now I've got the log by itself, I can do the inverse of the logarithm. The inverse of log base 3 is 3 to the power. So if I do 3 to the power on both sides, on the left-hand side, the 3 to the power log base 3 will cancel out to just leave me with 3b plus 1 over a minus 2. And on the right-hand side, I've just got 3 to the power minus 1, which is 1/3. I'm now going to multiply by a minus 2 over here and multiply by 3 over here. So I'd get 9b plus 3 equals a minus 2. I'm trying to express b in terms of a. So if I subtract the 3 from both sides to make b the subject and divide both sides by 9, I find that b is 1/9 of a minus 5/9. And that is my answer to part A, or part I rather. Part II, I need to solve the equation 2 to the power 2x plus 5 minus 7 lots of 2 to the power x equals 0. I can see I've got a 2 to the power 2x plus 5. I can split this up using index laws. So I could split this up and say this is the same thing as 2 to the power 2x times 2 to the power 5. Now that's going to be useful because then the 2 to the power 5, that's 32. So I've got 32 lots of 2 to the power 2x minus 7 lots of 2 to the power x equals 0. Now this 2 to the power 2x, that's the same thing as me saying 2 to the power x squared. Which is useful because this now matches up with this, and I can do some factorising. So if I factorise 2 to the power x outside here, I'm left with 32 lots of the 2 to the power x minus 7. Which means then either this has to equal 0, which I know it can't. 2 to the power x always looks like this. It can never equal 0, so I don't actually have to worry about this as a solution at all. I can ignore it completely. Or this bit would have to equal 0, in which case 2 to the power x would have to equal 7 over 32. And so x is log to the base 2 of 7 over 32, which as a decimal to 2 decimal places is minus 2.19. And that's my answer. So I did this via factorising. You could have done it as a hidden quadratic, because this is a quadratic. You could have made a substitution here, but I think my method is a little bit quicker and easier.